In this example, we're given the graph of a polynomial, and we're asked to determine the zeros of the polynomial. We're also asked to state the multiplicity, whether the multiplicity of each zero is even or odd. So to start, a zero of a function is any value a, where f of a equals 0. So when we're looking at this graphically, that means that the output value needs to be 0. So we'll look along the x-axis, and anywhere that we see that function either touching or crossing that x-axis, in other words, having a function value of 0, that input value will be the 0 of the function. So starting on the left here, we can see that at -5, our function value is 0. And again, at -2, that function value is 0. And lastly, we see it at 1 as well. So we know then that the zeros of this function are going to be -5, -2, and 1. As far as determining, so let's get all of those down first. All right, as far as determining the multiplicities, we're going to look at the behavior of the graph near each zero. And the shape of the graph itself will tell us whether the multiplicity of that zero is even or odd. So if we look at this first one, we have that zero of -5. And I've zoomed in just on the graph at -5. And we can see that at -5, the graph comes down, touches the x-axis, and then bounces back up. We could describe that behavior either as a touch or a bounce, but what's more so is that we can see that it looks like a little parabola at -5. And that's going to indicate then that the multiplicity of that zero is even, and more than likely it would be 2. So the graph looks like a basic function of x squared there. The multiplicity is going to be 2. Now I've said even and put 2 in parentheses because all we know for certain is that the multiplicity is even. More than likely it's 2, but it could be 4, it could be 6, it could be 8, and so on. We don't have any way of knowing for certain based on the graph whether it's 2 or 4. In most cases, we'll assume the lowest value. Okay, so if we continue on, at -2, we can see that this goes straight through. So it not only crosses that x-axis, but it goes straight through in a pretty linear fashion. So the 0 is -2, and that multiplicity is going to be odd. The reason it's going to be odd is that it goes from one side of the axis to the other. And the fact that it looks like a linear function there is going to indicate that the multiplicity of that 0 would be 1. We know for certain that it's odd. More than likely it's just going to be 1 though. And if we come to that last one, we can see that we're again going to cross that x-axis. But the distinction here is that this function isn't cutting straight through quite like a linear function. It's flattening as it does so. So that 0 is 1. And as far as stating the multiplicity, we're going to state that it's odd, but more than likely it's going to be 3. And what I'm basing this off of is that if we looked at y equals x cubed, it would have that same little shelf. And so in the same way that we use that parabola shape for y equals x squared to determine that the multiplicity was 2, we can see this little flattening behavior telling us that the multiplicity is probably 3. Could be 5, could be 7, but certainly odd.